Hey there guys, today we're going to talk about vectors, how to represent vectors, components of vectors, and what in general makes a vector. Well, what's unique about a vector is that two things have to be met for it to be a vector. First off, it has to have direction, and second off, it has to have a magnitude. When we denote vectors, we denote them as a variable. Now, typically, when we have variables, we set them equal to numbers like v equals 5 or v equals 10 or something like that. Well, these are scalar quantities. As vectors, we denote them as something different. So, as a vector, you typically denote it as the variable name with an arrow over the variable. This represents a vector. So when you see this being written, you should automatically think that this is a vector. Now, vectors, there's two-dimensional vectors and three-dimensional vectors. I'll first talk about two-dimensional vectors. So, like I said, vectors have to have a direction and a magnitude. So, let's start off by writing how a vector would look. And let's start off by making a little graph. So, here's our little graph, okay? And let's write a vector that has a let's write a vector. Let's just say 3i plus 5j, okay? And typically when you write these i's and j's, you should also put arrows over them to denote that they are vector. They are, components of a vector, and that they're not actually variables. So here you have a vector, and like we said, a vector has direction. So let's graph this vector. Basically, the way that you can look at this is that the I components, this is in the x direction, and this is in the y direction. The x direction is I, and the y direction is j. So something like this, 3 would be like down here, and 5 would be up here. So this would be our vector. And it has one, from our Cartesian graph, it does have a direction which is northeast. Now we have to figure out its magnitude. So how will we do that? Well, we have basically, we went over 3 units in the x and 5 units up in the y direction, denoted from this notation. So what do we have here? We have a right triangle. So if we want to find the magnitude of this vector, which in this case is the hypotenuse, all we have to do is solve the equation c squared equals a squared plus b squared. Okay? So when we do that, we figure out that c squared has to be equal to 9 plus 25. So c squared is equal to the square root of 34, which that is the simplest manner that you can, well, c is equal to the square root of 34. So we know that this, this vector, the vector 3i plus 5j, that from our graph, we know that its direction is northeast, and we know that its magnitude is square root of 34. Now, basically, to continue with the idea of the vector, let's write a different vector. Let's say now we have something like negative 3i plus 5j. Well, now, what's the only thing different? Our x component, which is our I vector, is in the negative territory, and we're in 5 in the y direction, so now this vector would be over here. But does the magnitude stay the same? Well, let's find out. Well, if we do the same thing, we have c squared equals negative 3 squared plus 5 squared, which equals 9 plus 25. So that means that c has to be again square root of 34. So all we did in that situation, we didn't change the magnitude of the vector, we only changed the direction. So basically, with two-dimensional vectors, they'll take the form of this. And think of this as being the notation that whatever number is here is how far you go in the x direction, and here this number is how high you go in the y direction. So yeah, that's how you denote vectors. In the next video, I'll explore three-dimensional vectors.